It is time to dive into another cutting-edge design field. And this time we are taking on parametric design. But what is it exactly? How does it work? And why is it so popular in today's world? These questions and many more will be answered in this video, where we will learn about one of the most fascinating branches of architecture that uses algorithms and other digital tools to create ever unpredictable yet coherent and logical forms. So let's get started. Parametric design is a technique used in various fields like architecture, engineering, science, computer science, design, and many others, where an object is created by defining rules or parameters that define how the object should be generated. It is basically a method of making that relies on variable relationships between different parts of the design rather than fixed positions. For example, if you wanted to build a wall, you would typically use fixed measurements to determine its height and width. But with parametric design, these measurements could be defined as variables and adjusted accordingly as needed. In other words, every piece of the design is connected together through a set of rules that control their behavior and interactions. And when one of the parameters changes, all other related elements adapt automatically, ensuring that the whole design remains coherent and consistent. This flexibility allows designers to explore a much wider range of possibilities and create designs that respond organically to their environment and context. In practice, parametric design utilizes various computational tools and algorithms to generate and manipulate complex forms and geometries which are difficult or even impossible to achieve through traditional design methods. One of the most well-known examples is the use of fractals, where complex patterns emerge from simple iterative processes. Other algorithms like L-systems or Lindenmayer systems allow for the creation of intricate designs that mimic natural phenomena like plants and trees. There are also various types of generative design algorithms that can produce unique and innovative solutions based on a set of design constraints and requirements. These tools and techniques enable architects to push the boundaries of creativity and explore new frontiers in design and innovation. Now let me show you some amazing projects that have been created using parametric design. And let me tell you why this type of design is becoming more and more popular nowadays. The power of parametric design lies in its ability to generate highly complex and unique forms that would be impossible to create using traditional design methods. By defining a set of parameters and rules, architects can create dynamic and responsive designs that adapt to their environment and user needs. For example, the Burj Khalifa, the tallest building in the world, uses parametric design principles to create its iconic shape, which responds to wind loads and environmental conditions. Another example is the Beige National Stadium, also known as the bird's nest, which uses a parametric design algorithm to generate its complex and interwoven steel structure. These are just two examples of how parametric design can create stunning and innovative structures that were not possible before. In addition to its ability to generate complex forms, parametric design also offers several other benefits that make it a powerful tool for architects. One of the main advantages is its flexibility and adaptability. As we mentioned earlier, once the parameters and rules are set, any changes to the design can be easily made by simply adjusting the input values. This makes it possible to create designs that respond organically to their environment and user needs. For example, if there is a change in the site conditions or user requirements, the design can be easily adapted without having to start from scratch. Another advantage of parametric design is its ability to handle complex geometries with ease. Using traditional design methods, working with complex geometries can be challenging and time-consuming, but with parametric design, complex forms can be generated quickly and efficiently using algorithms and other computational tools. This allows architects to explore a wider range of design possibilities and create innovative solutions that would not be possible using traditional methods. Furthermore, parametric design promotes collaboration and interoperability. The use of open-source software and data-driven workflows makes it possible for architects to work seamlessly with other professionals such as engineers and fabricators. This allows for a more efficient and collaborative design process and ensures that all members of the project team are working with the same up-to-date information. Finally, parametric design is a forward-thinking approach that embraces technology and innovation. By using cutting-edge tools and techniques, parametric design enables architects to stay at the forefront of their field and create groundbreaking work that pushes the boundaries of what is possible. Embracing this approach allows architecture firms to remain competitive and relevant in an ever-evolving industry. So now let me show you some great examples of parametric design in action that really demonstrate the power and potential of this approach. One of the most popular parametric design software is Rhino, developed by Robert McNeil and Associates. Rhino is a 3D modeling program that uses a non-destructive modeling approach, allowing users to modify their models at any time during the design process. This makes it an ideal tool for exploring complex geometries and creating innovative designs. Rhino also has a wide range of plugins and extensions that support parametric design workflows, such as Grasshopper, which is a visual programming language for creating complex forms and patterns. Overall, Rhino is a versatile and powerful tool for architects and designers who want to explore the potential of parametric design. Let us look at the work of Zaha Hadid architects who have been pioneers in the use of parametric design. One of their most famous projects is the Haydar Aliyev Center in Baku, Azerbaijan, a cultural center that uses fluid and dynamic forms to create a sense of movement and energy. The design of the Haydar Aliyev Center was inspired by the abstract qualities of Islamic art and the flowing curves of the surrounding landscape. The architects used a combination of parametric design and computer-aided design, CAD modeling techniques to create the center's unique form. This allowed them to explore a wide range of design possibilities and create a building that is both visually stunning and structurally efficient. Another notable project by Zaha Hadid Architects is the London Aquatics Centre, which was built for the 2012 Olympic Games. The centre's design features a series of interconnected ribbons that flow around the site and create a dynamic and fluid form. This approach allowed the architects to create a building that was not only functional but also symbolic of the power and energy of the Olympic Games. Zaha Hadid Architects have also used parametric design principles in their work on urban planning and master plans, such as the master plan for the Iraqi capital of Baghdad. The firm's proposal for the city's redevelopment includes a series of fluid and interconnected urban forms that aim to create a sense of continuity and flow within the city. Another great example of parametric design in architecture is the work of the firm 3148 Architecture, who have been recognized for their innovative use of complex geometries and dynamic forms in their projects. One of their most well-known works is the House of Music and Literature in Sarajevo, Bosnia and Herzegovina. The building's design is inspired by the city's rich musical heritage and features a series of interconnected spaces that flow around the site. 3148 Aba Partes. Architecture used a combination of parametric design and digital fabrication techniques to create the house's unique form. This allowed them to explore a wide range of design possibilities and create a building that is both visually striking and structurally sound. Another notable project by 3148's Architecture is the Zchem Center for Art and Media Karlsruhe in Germany. The firm's design for the center's expansion includes a series of fluid and dynamic forms that contrast with the existing brutalist architecture while still complementing it. 3148's Architecture used a combination of parametric design and digital fabrication techniques to create the center's expansion, pushing the boundaries of what is possible in terms of complex geometry and material performance. As you can see, parametric design is being used by architects all over the world to create stunning and innovative buildings that challenge the boundaries of traditional architecture. And now, let's talk about the future of parametric design. What trends and developments are shaping the field, and where do you see it going in the years to come? One of the most significant trends in parametric design is the increasing use of artificial intelligence and machine learning algorithms to generate complex forms and patterns. This is leading to the creation of highly innovative and unique designs that would not be possible through traditional design methods. Another trend is the growing use of parametric design in the construction industry to optimize building designs for factors such as energy efficiency, sustainability, and cost-effectiveness. This is driven by the need for more sustainable and resilient buildings in the face of climate change and other environmental challenges. Additionally, the use of building information modeling, BIM, and other digital technologies is enhancing the efficiency and accuracy of parametric design work, allowing architects and engineers to create more complex and detailed designs with greater ease. Moreover, the growing demand for personalized and customized design solutions is driving the development of new parametric design tools and techniques that allow for greater flexibility and adaptability in design processes. This is particularly relevant in areas such as urban design and landscape architecture, where there is a need for highly customized solutions that respond to the unique needs of each location. Furthermore, the increasing availability of high-performance computing resources and cloud-based platforms is enabling architects to explore more complex and data-intensive parametric design projects with greater ease and efficiency. This is opening up new possibilities for innovation and creativity in the field of parametric design. So, as you can see, the future of parametric design is bright, and we can expect to see even more innovative and groundbreaking work in the years to come. If you are interested in learning more about this exciting field, I encourage you to explore the resources and opportunities available to you. Who knows, maybe you will be the next pioneer of parametric design. That's all for now. Thank you so much for watching this video. If you enjoyed it, please don't forget to leave us a thumbs up and share it with your friends. We would love to hear your thoughts in the comments below. So go ahead and let us know what you think about parametric design and its role in the future of architecture. If you haven't already, be sure to subscribe for more videos like this one. Until next time, happy designing.